The second graph is, we are going to discuss on the graph on velocity versus time. Right? Velocity versus time. Remember, always look at the gradient. Say, I have this, velocity time. And this graph is a straight line graph going upwards. Okay. So, first of all, ask yourself, your gradient, V over T, velocity divided by time. Velocity divided by time is called the acceleration. And the acceleration, this is a positive constant. A positive constant. When this is a positive constant, that means it shows that it is the constant acceleration. Alright? Constant acceleration. Number two, you can also describe by the y-axis. So what does the y-axis shows? That it is a uniform increasing velocity. So the velocity is increasing uniformly. So this graph can give you two descriptions. One is constant acceleration, number one, increasing velocity uniformly. Can you follow? So these are the two things. Remember, you have to explain in terms of the gradient and the y-axis. B. What about this? This is V against T, and it is straight line like that. So for that, let's look at the gradient. What does the gradient? Velocity divided by time, which is acceleration, and this is 0. The gradient is 0. So when the gradient is 0, meaning from the no acceleration. There is no acceleration. Next, by looking at the y-axis, the velocity is always the same, never change. That means this is constant velocity. The velocity is always constant. The velocity is always the same. Alright? So this will give you the two descriptions of this graph. No acceleration, constant velocity. So constant velocity is 0 acceleration. The third one. The graph coming down. When the graph comes down, okay, when the graph comes down, so what does it show here? The gradient. Gradient, velocity divided by time. Velocity divided by time is acceleration. And this is a negative gradient. A negative constant gradient. So which means that when the acceleration is negative constant gradient, it is called a constant deceleration. Alright? A constant deceleration. And not just the constant deceleration, look at the y-axis. It is decreasing. Look at my hand, my finger. Smaller, 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 smaller. The velocity is decreasing uniformly. So the velocity is decreasing uniformly. Okay? Velocity is decreasing uniformly. Alright. Now, let's look at another one. What about here? V and T. But this time, I am now going to draw it downwards like that. On the negative side. So on the negative side, this is very confusing. Remember I told you? Look at the gradient. Gradient is V over T. V over T is acceleration. And this gradient is a negative gradient, correct or not? So negative constant gradient. But a negative constant gradient doesn't mean deceleration, because the velocity has changed direction. It is a negative velocity. It is a negative velocity. That means the direction has changed. Now look at my finger. It becomes more. You see? -1, -2, -3. So the velocity is what? Increasing. The speed is increasing. So this is where it is increasing. The speed is increasing uniformly, but in negative direction, in opposite direction. So when it's in opposite direction, this is not deceleration. It is still acceleration. It is a negative acceleration, but opposite direction. Can you follow? All right, with this, now we come to the importance of velocity time. Sometimes it is not just you must know the gradient. Assuming that I have, say, I start all over again, I want you to look at this area. Look at this area. Now, assuming that this is a triangle, the area of this triangle, this is the base in second. This is the height, b, which is a velocity, meter per second. So half times base times height will give you this area. However, I would like you to look at the unit. Look at the units. What is the unit for the A? A is second. What is the unit for B? B is meter per second. You see? I'm going to correspond it. This base is second. This height is meter per second. So when you have second times meter per second gives you meter. Meter is the unit for what? Displacement. So in other words, your area of velocity time graph will give you displacement. Very important. Velocity time graph, the area will give you displacement. Do not memorize. Look at the units. Look at the unit. What about distance and time? Distance and time graph. Area gives you what? No. Because time times meter don't give you meter second. Meter second has no quantity, no physical quantity. This one, the physical quantity is displacement. Can you follow? All right. So now I'm going to show it to you. Why this is important? Because in the displacement, I can give you something like this. This is velocity. This is time. So I'm going to have like this, the shape like this, and it's going down. All right. Now this one, say this is 0, this is 6, I have 4, I have 10, all right, and this is 12, this is also 10, all right, this is also 10, and then this is negative 6. Okay. Now you can see increasing velocity uniformly, constant velocity, decreasing velocity, opposite direction, speed is increasing. So from the whole graph, you know what it means already. So it is going opposite direction. Now, if I ask you to find what is the total distance traveled for the first 12 seconds. Now, in the total distance traveled, it is better for you to draw out. I'm going to have what we call a trapezium here, whereby this is 10 because the base is 10. And this is 4 to 10. 4 to 10 will be how much? So this is 6. All right, 6. And then the height. The height is how much? The height is 6. And the other one will be over this side. The triangle going downwards. 10 to 2. 10 to 12 is 2. Going down is 6. So you have two area. One is a trapezium, half times height times the addition of two parallel plus the triangle, half times 2 times 6. So the first part of the trapezium will be, this is 16, this is 3, sorry, cut 3. This is 16, 16 times 3 is 48, and this is 6. So the total distance traveled is 54 meter. Now we look at the total displacement. Total displacement. Total displacement, this is a positive displacement. This is a negative displacement. So it's minus 6 because it's going downwards. So that is where you have 42 meter. All right? So once you have this, then you should be able to find what is the average speed and average velocity. Okay?